Hello, and welcome to my video on how to do subroutines in Python. So, before I commence this video, I'm going to ask you to please like, subscribe, and share to this video, or subscribe to this channel. So, without further ado, I'm going to go over more subroutines, but this time on how to do different number system conversions. So there's 4. So you've got base 2, which is binary, base 10, which is denary, base 16, which is hexadecimal, and then base 8, which is octal. Okay, so we've got an empty program in our replit, and we need to figure out how we're going to create it. So what we will need to do, something like a menu. That looks a little bit like this. We've got 12 subroutines there. So what have we got? We've got convert to, and int input. So we're going to enter a number system that we want. And you can see we can't call any of these because these are not defined. So what we are going to do is define decimal to binary. Then we're going to enter. So what we need is decimal to binary, and we are going to input. We are going to do decimal. So we're going to input. So we're going to input a number to be converted, and then print out the equivalent. And what you'll notice is we've got the bin, that's binary, and then we've got the decimal number in there instead. So we've converted, so in there we will have converted denary to binary, okay? So I'll put the code in and then I'll show you how it works. Ideally, you should do bit by bit. You should be doing iterative testing and not so much the final test on a program like this. So what I'm going to do, I'm going to do 3 quotes. So shift, 2, 2, and 2. And then I'm going to go down on the other end and just do shift 2, 2, 2. So all this code's not going to compile, but all of this is. So let's click run. I'm going to enter a 1, and I'm going to enter 145. There is our binary number. 8. So we've got 1, 2, 3, 4, 5, 6, 7, 8 bits. Now 128. Add 16. Add 1. That's 145 in binary. Let's do decimal to octal. So this is where we convert decimal to octal. We're going to put these all in so we can see how each of these work. So that way I can show you how it works. So we'll take these out. So line tick. So we got decimal to octal. So 2. So I'm going to input a number like 90. So the number is going to be 132 in octal. And then what we'll do then, we've got decimal to octal. We need decimal here to hexadecimal. So we're going to click run. So we're going to do 3. So I want to input 90. It's going to be 5a, because what you do, you would convert 90 into binary, and then you would split the binary into 2 nibbles. So a nibble's 4 1s and 0s. and then you would convert those two nibbles into hex, which is why we will have the hexadecimal number. Okay? Okay, let's try binary to decimal. So let's say I wanted to convert 10100. That's 5100. That's 8. 164. Nice and easy there. So ask them to input a number, set the value to 0, did a for to do the len binary because it's 8. Then I did the digit equals binary pop. So pop is basically pushing off. The digits are 1. It's going to be value plus to the power of 2 with the I, the index. And then that's going to print the decimal value ultimately. Okay? So that little bit of a, so it's a little bit more involved than the others. Okay, let's run the next one. So we got hex to decimal. So I'm going to enter 5a. Answer's 90. So what we did with 5a, you convert those into binary. You've got your two sets of nibbles. Then we put the two nibbles into 1 byte. So that's 8 binary bits of 1s and 0s. And then we add up all the 1s. That's 90. Okay. So that's 5a. Hexadecimal to decimal. So now we need to do number 7, binary to hex. Let's also do 111000010. Okay, E and 2. Number 8, binary to octal. 1000 1001 211. It's your octal. So you can see what I've got here for most of these. So let's say we got binary to octal. So that's our number. So number 8. So I did 1000 1010. So I've done that number in binary format. So we've got a temporary variable, which is going to equal to int. So we're using the integer function, and we're going to wrap binary and a 2, because 2 is base 2. So we've converted it in binary. We're basically using the oct function, and then we're passing the temporary variable into it. So that's given us the octal number. Let's say I was to do number 9, octal to binary. So I'm going to do 212, and that's going to be a string. Using the string and integer function, the octal, then we put an 8 because it's base 8. Then we're going to use the decm, which is like a temporary variable, and we're going to do integer decimal number. Then we're going to print what the octal is, and we're going to use the binary equivalent, and then pass the decm into it as our variable. So that is how we get the binary number from the octal. And then we got octal to hex. That's number 10. Let's say we were to enter a number in octal format, 212. That's going to give us 8 and A in hexadecimal. That's what we got. Got the string octal being 8. Int these based on decm variable. All these are the same. Difference is we're using the hex function rather than the binary function to get our hex number. If we were to do hexadecimal to octal, so I'm going to do 8a. So input the hexadecimal number, int hexadecimal 16 because hexadecimal is base 16. So we're using the oct function and we're passing DEC into that. And last but not least, hex to binary. So let's suppose to do 6A. It would just be right. We've got 4, and we got 4 here. So 0, that's your 8. 1 is your 6. 1 is your 4. Because 6 and 4 is 10, but we write 10 in hex to be A. Hang on. My bad. My mistake. So we got 0, 1, 1, 0. So 1, 2, 4, 8. So 4 and 2 is 6. So 0, 1, 1, 0. That's your 6. And then you got 1. That's your 8. 0. We don't add 4 to that. Your 1. We add 2 to that. 0. We don't add anything to that. So 1, 0, 1, 0. That's 10. Because 8 plus 2 is 10. 10 in hex. That's A. Okay? So I've showed you how to. So I've went through all of these pieces of code on how to convert between each of the number systems which we would need in computer science, or some of them, because there's a whole lot more to it. Binary addition, binary subtraction, binary multiplication, etc. And this is the whole final piece of code. If you've enjoyed this video, please remember to like this video, subscribe to my channel, and share this channel far and wide, and I look forward to making the next video for you very soon. Goodbye for now.